Hmm? Do you remember this part? Integration part, do you remember? Okay. Okay, Mankata. Yeah, Saitya is correct. Okay, so that's why I'm writing the total work done is integral dW, means addition of all small work done. Okay, na? So integral dW I can write down, total work done I can write down integral dW. What the dW is? F ds cos theta. When force is constant, I can write down this one as F bar dot directly S bar. When force is constant, I can write down F bar dot S bar, integral ds. What the S bar now stands for? S bar stands for direct displacement vector. This is the displacement vector. No need to see the path. Okay, na? S bar is the displacement vector. Here S bar is displacement vector. Displacement vector from where to where? From initial point to. From initial point to final point. Okay, na? So whenever you are dealing with the constant force, if force is constant, then no need to see the path. So I can say that it is path independent. I can say that it is path independent. So no need to see the path. It only you have to see what? You have to see the initial point and final point. When force is constant. Board is blur. For me there is no issue. What about remaining? What about remaining people? Board is clear or not? Andarki blur unda. So then there is an issue with the internet. Okay. On YouTube also it's blur. Huh? Saichar, I can understand. Now okay na? Clear? Yeah. Okay. So when force is constant vector, constant force. What is the meaning of constant force? Direction and magnitude both should be constant. Direction and magnitude both has to be same. So under that condition, when force is constant, then only you can write down F bar dot S bar. Okay, otherwise you cannot write down F bar dot S bar. Why? Because when force is constant, integral F ds cos theta will become F bar dot S bar. Okay. Okay, Praveen. Okay, na? When force is constant, you can write down F bar dot S bar. Remember this. And remember, when force is constant, directly you can take what? A displacement vector from initial point to final point. You can take direct displacement vector. No need to go with the path. Path independent. It does not depend on the path. When force is constant. Clear? Wrote down? Shall I go to next part? When force is variable, what to do? If force is variable, we have to integrate. There is no other alternative. If force is variable, we have to integrate. We have to do the integration. Maybe theta variable, maybe magnitude variable. Okay, na? So according to the force and angle, you need to integrate. Okay. Finished or wrote down or writing? Completed, very good. Next, if force is variable, okay. If force is a variable, if variable force is there, then how to find out the work done? So total work done should be written as what? Integral dW, everywhere integral dW on. dW is the defined quantity. dW is the known quantity to us. From the dW means small work done, you have to develop for the total work done. Understood the logic? dW is a known quantity, dW is the defined quantity to us. అంటే dW అనే వర్క్ డన్ మనకి ఇచ్చారు, మనం ఏం చేయాలి, మనం టోటల్ వర్క్ డన్ ఫైండ్ చేయాలి. Then we have to use integration. If it is constant force, we know it will become F bar dot S bar. Okay na? If force is variable, then what happens? You have to integrate. There is no other option. You have to go for integration value. Okay, so how to do integration, that all we see in the questions. Okay na? So now make a note related to work done. So as it is dot product, work done by a force can be positive, no? Work done by a force can be positive. So when work done by a force can be positive, when theta is less than 90. If theta is less than 90, what is the cos theta value? Cos theta value is positive value. Cos theta value is positive, so that's why work done can be positive. And second thing, work done can be zero also. Work done by a force can be zero. When it will be zero? When work done by a force can be zero. Yes, Bhavana, correct. When work done by force can be zero, when theta is equal to 90. So obviously force should be there. Without force, we no need to say that work done. Okay. If force is acting but still work done is zero, means angle is 90. And work done can be negative also. Work done by a force can be negative. When negative? When theta is more than 90. If theta is more than 90, work done can be negative. Okay, so all the three are possible, and work done is a scalar quantity. And what are the units? SI unit is joule, and MKS unit or CGS unit is ergs. Okay, na? Erg and what do you say, that joule are the units. So I think don't think this one. So now he is applying the constant force at an angle theta, and displacement is d. Then what is the work done by him, or work done by the force applied by him? Now it's a constant vector. F bar is constant force. What we can write down? F bar is a constant force. Then what is the work done by? See, I'm not simply writing work done. Work done by applied force. Work done by applied force by the man. Work done by applied force by the man. That I'm writing. See, always you have to, Fs cos theta, Fd cos theta. Always you have to mention work done by which force. Okay, na? So don't write simply work done. Work done by which force you have to write down. Okay. So work done by applied force by the man is equal to what we can write down. Now it's a constant force. So simply we can write down F bar dot S bar, as it is constant force. Okay, na? So I can write down F into what the displacement is. Displacement is D. D is the displacement as given, D bar. What the angle between the force and displacement is? Theta is given, let us say. Then Fd cos theta. Fd cos theta. Okay. Now why I'm discussing this? Because it has some importance. Now let us see. This is the force vector, and this is the displacement vector. What are the angle between them is theta. Now what I'm doing is I'm making into components of D. I'm making the displacement components. If I make displacement components, I'll get one component is d cos theta along the force, other component is d sin theta. Okay, na? I'm making the displacement into two components, d cos theta and d sin theta. Now this force is perpendicular to d sin theta. Force is perpendicular to d sin theta. Then what is the work done in displacing the d sin theta displacement? So now I'm taking the two displacements. Okay. I'm not taking the one displacement, I'm taking the two displacements. D is the actual displacement, one displacement only. But I'm splitting into two displacements. Okay. One is d cos theta, other one is d sin theta, let us say. Then what is the work done in displacing the d sin theta? Work done by the force in displacing the d sin theta. Let us say there is no d cos theta, there is no d sin theta. Only, sorry, d cos theta, d is not there. Only d sin theta is there. Then what is the work done by the force? Zero. Because force and displacement both are perpendicular to each other. Both are perpendicular to each other, zero. So there is no work done in displacing the d sin theta. So force is doing the work in displacing the what? D cos theta only. Okay, na? Force is doing the work in displacing the d cos theta, not d sin theta. Glory. See, this is the force, let us say, and this is the displacement d sin theta. Only take these two. Then what the angle between them is? 90. Then what is the work done by this force in displacing the d sin theta? Work done by the force in displacing the d sin theta. Zero, no? Because both are perpendicular. Already we discussed. Work done by force can be zero when theta is 90. When they are perpendicular, there will be zero. Instead of one displacement, I'm taking the two displacements. I'm making into components. Okay. So in d sin theta displacement, there is no work done by the force. Okay. Understood? So there is no work done in displacing the d sin theta. There is a work done by the force. Our force has to do work in displacing the what? In displacing the d cos theta. Work done, if displacement is not there, there is no question of work done. If force is zero or displacement is zero, no need to talk about the work done. You can leave it. Am I right or not? Okay, it's something like if you're getting the 0 marks, then what is the use of talking about fail and pass? Something like that. If anything is zero, then no need to discuss. Force is there, displacement also there. In circular motion, not displacement zero. Don't think that it's displacement is zero. Displacement in round trip is zero. Total location ready. In circular motion, total revolution, displacement is zero. Okay, na? So that is different. I tell you, wait. Again, board is blur. I think today internet problem. Maybe. Andarki blur unda? Only you people are on the blur. What about remaining? Board is clear? Okay. So I can write down this work done can be work done. How to write down? Work done, I'll write down F into d cos theta. I'm writing. What is the meaning of F into d cos theta? Work done, I can write down. Force is multiplied with displacement in the force direction. I can write down. See once. What is the displacement in the force direction? In the force direction, what is the displacement? In the force direction, displacement is d cos theta. Okay. So then force into displacement in the force direction, I can write down. Charanteja. So maybe internet speed problem today. Everybody is getting blur. Huh? Just a minute. I'll leave and log in again. Okay, so my internet speed is very good actually. Uploading speed itself is 100 Mbps. Download speed is almost 400 Mbps. Hmm? So I don't know. ఎవరున్నారు host? సాయి సారా హంజీ సారా host ఎవరున్నారు? Now it is clear. Hmm. Okay. Hmm. So what I want to say here is, whenever work done by a constant force is there, work done by constant force is there, whenever it is work done by constant force, then you can write down like this: force into displacement in the direction of force. Why? Because F, what is the displacement in the direction of the force, is d cos theta. D sin theta is the displacement perpendicular to force. So whenever displacement force are perpendicular, then work done is zero. Okay, na? And what is the displacement in the direction of the force? D cos theta. So that's why I can write down the force into displacement in the direction of the force. Similarly, you can do another way. What is the other way is, now let us see. This is the displacement. This is the force, let us say. What is the angle between them is theta. Now instead of displacement, what I'm doing is I'm making the force into two forces. I'm taking the F into two components. One is F cos theta, other one is what? F sin theta. Now instead of one force, I'm taking the two forces. Now tell me which force will do the zero work done. Which force is not useful for doing work? Which force is not useful? F sin theta. Because F sin theta is perpendicular to displacement. So F sin theta is perpendicular to displacement. Work done by F sin theta is zero. So then I can write down the work done as, how to write down the work done now? Work done is usually what? F d cos theta. No, this is the work done. This I'll write down like this: F cos theta into d. I can write down F cos theta into d. If I'm writing the F cos theta into d, I'll say that force in the direction of displacement, force in the direction of displacement, okay, multiplied with the displacement. Okay, na? Anyway, you can solve it. You can do force into displacement in the direction of the force. You take the total force and you see the only displacement in the direction of the force. That is the one way you can take. What is the other way you can take? The other way you can choose is, you choose the displacement totally and you concentrate what is the force acting in the direction of displacement. You see what is the force acting in the direction of displacement. I think you understood both the statements. You can follow any one of the statement according to your choice, your convenience. Okay, na? Writing? Okay, finished, wrote down. So when work done by a constant force is there, you can apply these logics. Force into displacement in the direction of the force, or force in the direction of the displacement multiplied with the displacement. Okay, finished, wrote down. If you wrote down, let me know. Okay, Sajesh, are finished. Very good. What about others? Previous page, huh? Okay, Mankanta. So this is the work done by variable force. When force is variable, total work done is integration we have to apply. Huh? We need to use integration when force is variable. Remember that. Completed? Huh? Mohit ready? Hmm. Done? Finished? Huh? Hmm. Okay. So next, these are the some zero work done cases. Okay, na? Work done by force will be zero. So these are the some cases where you'll find work done by force is zero. So one person is holding the bag, shopping bag, then force will be upward. So if he is moving forward, displacement, then what is the angle between the force and displacement is 90. Then work done by him is zero. Work done by force applied by him is zero. So here gravitation force is acting downward. Box weight mg will act downward, and person is applying the force upward, let us say. So actually person won't apply the force upward, person will apply the force horizontally, normal reaction, friction will act upward. Okay. But we are saying that person is applying the force upward because ultimately he has to apply it. Then work done by mg and work done by force F both will be zero because the displacement is along the horizontal. If he is moving along the horizontal, work done will be zero. Work done by gravity is zero, work done by F also will be zero. Okay. So these are the zero work done cases. Okay, finished. No need to write down, just try to understand because drawing will be tough. Okay. Whenever force and displacement are perpendicular to each other, then work done will be zero. That is the logic you need to understand. Okay, finished. So these are also some other zero work done cases. One man is pushing the wall, so then he'll apply the force. But here the displacement of the wall is zero. Displacement of wall is zero. Okay, so as displacement of wall is zero, then we can say that what is the work done by him? Work done by him, okay, work done by man or work done by force applied by man is zero. So previous case, mg is acting downward, but he is moving in forward direction displacement. Both are perpendicular to each other. So then what is the work done by mg? Work done by mg is equal to 0. Okay, now work done by weight is 0. Now this is the what is the circular path? When a particle is moving in a circular path, this is very important term. Then work done by centripetal force is 0. Why? Because see, this is the circle. Okay, na circular path. Now if I take a particle, then what is the force acting on the particle? The force will act towards the center. Okay, na? If I'm considering the small displacement, I told you whenever we do the work done, always we have to start from the small work done. Take a small part and find the work done, and then go for and see the total work done. Okay, that is the scenario. Always you have to do in that way. You have to solve from the small work done. Okay, na? So if I do with the small work done, how the small work done is? The small work, so small displacement is ds bar for small work done. Now tell me how the ds bar in force. Small work done is nothing but along the tangent. This is the tangent line. In any path, what is the displacement? Small displacement means along the tangent. Along the tangent, small displacement will be there. Okay. Now, force is along the radial. For this is the center. Force is along the radial. How the radial and tangent are? Radial and tangent both will be perpendicular to each other. That means how the force, centripetal force is always perpendicular to displacement. Every instant. At every instant, centripetal force is always perpendicular to displacement. Okay, na? Centripetal force is always perpendicular to displacement. If you want to write down, centripetal force is always perpendicular to displacement. Okay, na? Perpendicular to displacement. So as centripetal force is always perpendicular to displacement, what is the work done by centripetal force? Work done by centripetal force undoubtedly 0. Okay, don't think that displacement is 0. Particle is coming to the same point. Displacement is 0 in the circular motion. That's why work done is 0. That's not the reason. Work done is not 0 because of displacement is 0. Why work done by centripetal force is 0? Centripetal force is always perpendicular. Let us say we take some other point here, small part. If I take some other small part here, then centripetal force will act towards the center. Now centripetal force is not constant force, it's a variable force. Centripetal force direction keep on changes. Okay, na? Centripetal force is variable force, but what is the advantage we are having? We are having the advantage here, the displacement vector is the ds vector. Displacement vector is what? How the displacement vector is along the tangent always. So what is the angle between the displacement and centripetal force is 90. So like that at every instant the centripetal force is perpendicular to displacement. That's why work done by centripetal force is always 0. Manish, centrifugal also will be 0, no? Obviously, opposite to centripetal, centrifugal will be there. Okay, so work done by centrifugal also 0. But when to apply centrifugal? Centrifugal is nothing but pseudo force. If you are in non-inertial frame of reference, then you have to apply centrifugal force. Okay. Praveen, okay, good. I think Tejashwar Reddy told displacement is zero in circular motion. Tejashwar Reddy, am I right? Tejashwar Reddy or Lokeshwar Reddy? Somebody, did remember? So don't think that work done in the circular motion is zero. Work done by centripetal force in circular motion is zero because centripetal force is always perpendicular to displacement. Okay, so that's why work done is zero. Don't think that in a complete circular motion, in complete circle, the displacement is zero. That's why work done is zero. Okay, Lokeshwar Didana. All of you wrote down? Finished? Wrote down? Well, let me know if you finished it. If you wrote down, let me know. Completed, Sai Charan? Okay. Sai Charan finished. What about remaining? Okay, shall we move to the next part? So, whenever it is work done by variable force, work done by variable force we are talking about. Okay, na? So, what is the work done by variable force is? Work done by variable force. Variable force I can write down what? Integral dw, which is nothing but integral f into ds cos theta. Integral f into ds cos theta. So this is the work done by variable force. Am I right? This is the thing what we got. Now let us say if force magnitude is variable, direction of the force in the direction of the displacement. Okay, na? Or else I'm taking a one case. Take a case, okay, na? Particular case. What is that? If force acts along x-axis, okay, na? Positive x-axis. Let us say force is acting along the positive x-axis, and particle moves along positive x-axis. Okay, na? And force magnitude is variable. So then how to write down? Force magnitude is variable. Force magnitude is varying, but what is the force direction? Force direction is along the positive x-axis. Even particle also moving along the positive x-axis. Then what is the angle between the force and displacement? What is the angle between the force and displacement? Okay, read the statement once. Once read the statement and forget about this. I'll explain this part. First, concentrate what I'm explaining. Work done by variable force means we need to integrate. That we know already. Now the question is, see, if force is acting along the x-axis, positive x-axis, and particle is also moving along the positive x-axis, then, but force magnitude is variable. Magnitude of the force is not constant, variable. Then what is the scenario? The scenario is simple. What is the angle between the force and displacement? Force is positive x-axis. Displacement also positive x-axis. Then what is the theta value? 0. Very good. So what is the angle between the force and displacement is 0. Nice. Okay, na? So then I can write down as what? Theta value is equal to 0 and cos theta value will be equal to 1. Then what the total work done is? Integral dw, which is nothing but integral f into, I'll write down the dx. Why I'm writing as dx? See, ds is a general term. You can change the ds into dx, dy, dz anyway. No issue. Your choice. Okay. Na? So integral f into dx I can write down. Where f is variable and dx is the displacement along the x-axis. So then integral f dx. What is the meaning of integration? Integration means area under the graph. See, this is the area. This is the graph. F magnitude. Force acting along the x-axis is changing. Magnitude is changing with the x value. Let us say. With the x value changes, then integral f dx will give you area under the graph. Do you remember the integration or not? Integration stands for area under the graph. What about derivative? Derivative stands for slope of the graph. Derivative will give you slope. Integration will give you area. So that means what is the display? What is the work done? Work done in moving the object from initial position to final position. The area below the graph. If you calculate the area value, you can find out the work done value. Okay. So area value is equal to work done only. Remember this one. Okay. So area is equal to area under the graph. Area under the graph is equal to work done. Okay. Understood? Here force magnitude is varying. Force magnitude is varying. So that the graph we have drawn. So graph will tell you how the force is changing with the position. So work done from initial position to final position. Work done from initial position to final position will be given by what? Will be given by area under the graph. Okay. But to do all these things, what is the theta value we have taken? We have taken theta 0. Okay, wrote down. Writing. Work per energy is very important chapter for entire mechanics. So here conservation of energy, okay, work energy theorem, all these are plays very important role in solving the questions. Today you are having the exam, no? Today in the evening. Okay. Write down carefully, particularly physics. Hmm? Okay. Do well. Think before answer, and don't do mistakes. We'll come to school, Sai Charan. We'll come to school, but when we don't know. Like maybe we are thinking like in December first week. Let us see. Hmm? Okay, na? From tomorrow it is reopening, huh? Okay. We'll be coming to school. Hmm. Yes, I think I'm coming. We'll teach there only. We'll teach offline only. Okay. But when is a little question mark, like December first week. Venkatattam sir is saying December first week. Let us see how this. I mean, Subbareddy sir and Venkatattam sir will decide. Huh? Okay. Yeah, station correct. I'll stay there only. Right now I'll come and soon I'll shift the family also. Okay. Yeah. Once college starts, no, I'll stay there only. Like my family will stay there only. Okay, because some people are opting for, I mean, some people are thinking for offline and some people are thinking for online, no, it seems. Hmm? So let us see. Okay. Sai Charan, that's only I'm saying. The plan we don't know. Okay. So according to plan, we will be there. But don't worry, we will meet you. Okay, whether teach or not, okay, na? Whether class is going or not, we will meet. We'll come there. We'll come to school and we'll meet. Praveen, you wrote. Okay, yeah. So there we can you can ask the doubts. You can clear your doubts and all, na? Okay. Sacharan, how you? I can mostly I can identify also. Not only name. I can identify your. I can identify you, I can identify Praveen, I can identify Sai Teja, I can identify Glory, I can identify Lahari. Hmm? I cannot identify Adil. Adil is a burning fellow, no? Always burns. I don't know whether he is there or not. Still he is there because burning from long time. Lokeshwar Reddy, have to see once. If you switch on your videos now, I can identify your people. Manish, I can identify. Yeah, let me see how many I can identify. Huh? Most of the times, if you are keeping your video on, I can identify. Location Reddy, I can identify you. Okay. Gopal is tough. Gopal, I have seen very less number of times Gopal. But I remember the name Gopal Reddy. Why Gopal Reddy? Okay. So we'll meet very soon. Huh? We'll meet very soon. We will exchange our ideas. Okay. Okay, finished. Wrote down this part. Gopal, by the time I'll come to school, I'll identify. Don't worry. Don't worry. Bhavana, I have to see. Okay, solve this question. I hope you are able to read the question. A block of mass 20 kg is moving on a smooth surface, so friction is not there. By pulling through a light string of tension 10 root 2 at an angle 45 degree. It's a very easy question. Find the work done by string on the block for a displacement of 2 meter along the surface. So the block will travel 2 meter displacement along the surface. Then what is the work done? It's a very direct question. Apply the formula. Manikanta 20 joules, sir. Very good. Very good. Manish and Manikanta both has given very fast. I think remaining people are copying the question. These fellows did the question. Glory also given answer. Very good. 20 joules. Ajay got 20 joules. Bhavana also got. I think everybody has to get this answer. This is very easy question I kept. Because first question, no? Now force is constant or variable? 10 root 2 is nothing but what? It's a constant force. It's a constant force. When force is constant, what to do? Directly apply the formula. When force is constant, what is the work done by the force? I can write down F bar dot S bar. Okay, so work done can be written as Fs cos theta. So work done is equal to work done by the forces. What the force value is? 10 root 2. Okay, now what the displacement is? 2 meter. What is the angle between the force and displacement? Angle between the force and displacement is 45. So cos 45. Okay, na? So what is the work done? I can write down 10 root 2 into 2 multiplied with 1 by root 2. Root 2 cancel out. You will get how much? 20 joules. That is the work done. Gopal already correct. So most of the people did this question. Good. Very good. Okay, na? Finished? Wrote down? Yeah. So let us go to the next question. Finished? Saiteja, very good. What about remaining people? Remaining people did this or not? So this is a question can be done by anyone, I feel. It's an easy question only. Completed? Very good. This is the next question. A triangle block is moving horizontally with constant velocity V naught. It's moving with constant velocity V naught. A small block A of mass M is fixed on the triangle block. Then work done by friction on block A in time t will be. Think about it carefully and solve. A small block A of mass M is fixed on the triangle block. Fixed means does not move. Does not move on the inclined plane. Let us say this is the inclined plane. On the inclined plane, this block is not moving on the inclined plane, but inclined plane is moving. Inclined plane is moving, but on the inclined plane, block is not moving. Okay, that is the thing they have given. Think about it. And the work done by friction on the block in time t, they're asking. I say that it's not easy, at the same time not tough. It depends on your thinking process. If you think from the hints of the question, it is easy. Otherwise, you will be a little blank to solve the question. Okay, na? So already I have given the hint. One is what? One hint in the question. Block is not moving on the triangle block. That is the one hint. Block is not, no Manish, it's not zero. FV Vt cos theta, na? Mg sin theta Vt. Manikanta, yes, you are very close, it seems. Lokesh Reddy also wants to revise your answer. You people are very close. Even Mohit Reddy got sin square theta, na? Mohit Reddy, it's sin square theta, I think so. Yes, you people are very close to answer, it seems. See, block is not moving on the inclined plane. So they have given triangle block. Triangle block, you can call it as inclined plane also. I'm taking it as inclined plane. Okay, na? Yeah. Okay, so on the inclined plane, block is not moving, but inclined plane is moving. It's something like that. You are not moving inside the bus. Means you are just sitting on the bus. I mean, sitting inside the bus. Bus is moving. Bus is moving means you are also moving. So something like that. Imagine you are sitting inside the bus. Bus is moving. You also will move. Okay, na? So it is moving with V naught constant velocity. In what time you have to find out the work done? In t time. Now let us say what is the work done by friction. They're asking the friction, work done by friction. How to identify the frictional force? How to identify the frictional force? Mg will act downward direction and make the components. What are the components? Mg sin theta will act down the inclined plane and mg cos theta, because theta is the inclined or inclination. Mg cos theta, we know this thing. Normal reaction is n. Now the question is, what is the frictional force value? Mu into normal reaction. Can we write down frictional force as mu into normal reaction? Can we write down frictional force as mu into normal reaction? No, we cannot write down. Why? Because does not move. Does not move means what is the friction force will act? Static friction will act. Static friction will act. Okay. Static friction force will be equal to, static friction will be equal to what? Will be equal to applied force. Then what the friction force value is equal to? Friction force value is equal to mg sin theta. Don't apply the formula. Formula you can apply for kinetic friction only, not for static. Static friction is equal to applied force. So what is the friction force value is equal to mg sin theta. Praveen, wait, we will solve it. Mg sin theta. Okay, na? This is the friction force. But what is the displacement? How the displacement is? So as the triangle block is moving forward, the displacement of the block will be horizontal. This is the displacement. This is the displacement direction. Am I right? As the triangle block is moving forward, this block, whatever this block is there, that block will move along the horizontal. What the displacement of the block is? Displacement of the block is horizontal. Am I right or not? See, on this incline, this object is there. Incline is moving forward. As incline is moving forward, object also will move forward. Horizontal it will move. This is the displacement direction. This is the force direction, friction direction. You people have seen the friction, you people have calculated displacement, but you people didn't see the what is the angle between the force and displacement. Now this force, friction force is constant force or variable force? It's a constant force. It's a constant force. Work done by constant force we know already. Now the question is what is the angle between the displacement and friction? What is the displacement value? It is moving with constant velocity in t time. What is the displacement? I can write down v naught into t is the displacement. Displacement is v naught into t. Am I right? V naught into t is the displacement. Friction is the force. Then what is the angle between them is? How to go for angle between them is? This is the incline. Incline makes an angle theta with the horizontal. Displacement is this, which is v naught into t is the displacement. How the friction force will act? Friction force will act along the incline and upward direction. Then what is the angle between these two vectors? What is this angle? Obviously this angle is theta. Then what is this angle is? Pi minus theta, which is 180 minus theta. So angle between the displacement and frictional force is 180 minus theta. Then what is the work done by friction? Now I can write down. Work done by friction I can write down as work done by friction is friction is how to write down? F bar dot S bar formula I can apply. Why? Why I am able to write down the F bar dot S bar? Because force is constant. If force is variable, we have to go for integral F ds cos theta. Okay, now we have to use integration. So as force is constant, I can use F bar dot S bar directly. Then I can use F bar dot S bar, frictional force into displacement into cos of angle between them, which is pi minus theta. So what is the friction force value? Friction force value is mg sin theta. What is the displacement value? V naught into t. Cos of 180 minus theta minus cos theta. Okay, understood? So finally, what is the value? Work done value minus mg v naught into t sin theta into cos theta. This I can write down as minus mg v naught into t sin 2 theta by 2. Sin theta cos theta I can write down sin 2 theta by 2. That is the work done. So some people got sin square theta. So check it once. Why you are getting the sin square theta? Because of angle mismanagement, or else you wrote mu mg cos theta now. Friction force. Don't write friction force is mu mg cos theta. Mu into normal reaction you can write down in kinetic friction only. When it is sliding, but it is not sliding. It is at rest on the triangle block or on the inclined plane. All of you okay now? Verified? In t time, V naught into t is the displacement. All of you verified your mistake or not? So this is the place where you have done the mistake. The first mistake, the place of first mistake is frictional force. Frictional force value should be mg sine theta, not mu into normal reaction. Second place to do the mistake is angle between the displacement and friction. These are the two places where you can do the mistakes. We will do the mistakes. Okay. So try to rectify it. Okay, finished? Wrote down? Completed this one? Okay, so we solve the some other questions on work done tomorrow. Tomorrow we'll discuss the questions related to work done. Okay. Yeah, all of you wrote down or writing? So tomorrow we discuss the some other models on work done. So all of you, work is negative because angle is more than 90. Theta less than 90 we are taking. If theta is less than 90, then angle between the force and displacement is more than 90. Lokesh Reddy, understood? That's why it is negative. We discussed, no? Work done can be positive, work done can be negative. So similarly, okay, no? Done? Finished? So we'll discuss some other models on work done. Please revise all these things. Revision is must, and important also. Okay? Yeah. So bye everyone. So meet you tomorrow. Bye everyone. All of you wrote down, or still writing? Anybody? Completed? Okay then. Bye everyone. Bye. Bye Mankanta. Bye bye.